Hello students, in this class we are going to discuss about shift through a glass slab. Before going to start this topic, we will recall the previous one. In previous class, we studied about real depth and apparent depth. If an object immersed inside the water, if we look at certain angle, then it appears that it is elevated from the water, from its actual depth. Then we study the formula mu2 by mu1 equal to d by d dash, that is real depth by apparent depth. We always take mu2 when light is coming from the object. So that medium is mu2. When light is going towards our eyesight, that medium is taken as mu1. Then we solve certain numericals based on real depth and apparent depth. So here, shift through a glass slab. We will draw a glass slab. So this is one glass slab. An object is placed here. Say here an object is placed and we draw an axis. A person view this object from here. Okay, so light is coming from the object. If the person see it from here, light is coming from the object. Say one light is going like this. Here we have air, here we have glass. So what will happen? Refraction takes place. When light travels from one medium to another medium, it bends. So light ray bends. In which direction it bends? Towards the normal, because it is moving from rarer to denser medium. So it bends towards the normal. Okay, it bends towards the normal. Again, here we have air and here we have glass. So two different medium. Again it bends. In which direction? Here light is going from denser medium to rarer medium. If it is go from denser medium to rarer medium, then it bends away from the normal. Okay, it bends away from the normal. Correct? So if we join this, line, it is entered here. So here the final image will be appear if a person see it from here. Okay, so this is known as lateral shift or shift through glass slab. This is actual object, but for our eyesight it is seen here. Okay, so this distance known as shift. Yes, clear? We have a formula for shift. Shift S equal to T 1 minus 1 by mu. Where mu is the refractive index and T means thickness of the glass slab. Okay, so we will solve how to get this formula. Let's take this is thickness of the glass slab T. We have two interface here. You see here air and glass. Okay, this is one interface. So we take this is first interface. Then glass and air, glass air. So this interface taken as second interface. Just like we solved in previous problem. Okay, remember that previous problem. So similarly, we will solve first one. First interface. What's the formula for real depth and apparent depth? Mu2 by mu1 equal to d by d dash. Correct? So this is the formula. Now tell me what is mu2? What is mu2 here? Light is coming from air. See, this is our object. Object is located in air. So light is coming from air. That is mu2. So mu2 value 1, refractive index of air. Okay. Mu1 is nothing but the glass refractive index. We don't know it. We take it simply mu. Clear? Then D means depth, real depth. We always take depth from the surface. Okay, so this is our surface. Then the distance of surface and the object taken as real depth D. Okay, for example, we take this distance as x. So here instead of D, we take the distance x by D dash. Then D dash equal to mu x. Okay, for first interface. Then for second interface, we take glass air. This is our second interface. Apply the same formula, mu2 by mu1 equal to d by d dash. So what is mu2 here? Light is coming from the glass. Okay, light is coming from the glass. Now mu2 is glass. For glass, the refractive index is mu divided by, what is mu1? Light is going towards air, going towards our eyesight. If we see from here, going towards our eyesight. Okay, for air refractive index, it is 1. Then what is D here? So first we mark this point. We found D dash equal to mu x. Correct? So where this D dash appear? D means real depth, and D dash means the D dash appears when you extend this line. Okay, when you extend this line, and this point is our D dash. Okay, so this O is our D and this point is D dash. What is the value of D dash? D dash equal to mu x. Clear? Why the distance increased here? This is our actual distance, but our appear distance increased. Why? Because we are viewing this point from the glass. First I consider first interface, air glass. So first interface means we are viewing this point O from the glass. So if I look from denser medium, then the point distance will increase. Okay, if I look from denser medium, distance will increase. So that's why distance is increased up to here. This is actual distance, but distance increased. That distance is mu x. Okay, now come to second interface. So light is going from glass. We take mu2 as mu. Light is going towards air, coming from glass, going towards air. For air refractive index is 1. Then d by d dash. What is d? D means real depth. Real depth from where? Real depth from second interface. So this is our second interface, and second interface to this d dash is known as our real depth. Okay, second interface to d dash. So this is our real depth. Correct? So for this real depth, we have this value t and this value d dash, that is mu x. Okay, from here to there, that is we found here d dash, apparent depth, that is mu x. Okay, so t plus mu x. Our answer is t plus mu x. That is our real depth for this interface. As I said already, image of first interface behave as object of second interface. So now this is the object of this interface. That's why we take D, real depth. Okay, this is object of second interface. So for object depth we take D. Correct? So our D value is t plus mu x. T plus mu x divided by d dash, that we have to find. Clear? So d dash equal to mu into t plus mu x. Sorry, mu come here. D dash equal to cross multiple t plus mu x divided by u. Okay, this is our d dash value. But our motive is we have to find the shift. We have to find the s value, not the d dash. Okay, we have to find s value. So what we just found here, we found the final image, which is get from the second interface. From the second interface, if I extend these lines, then it joins here. This is our final image. So we just found the distance of final image. We just found this distance, that is t plus mu x divided by mu. Okay, we found this distance, but our motive is we have to find this s, lateral shift, that is distance between object and final image. That is our motive. Okay, so how to find it? Let me name this as our point A. So if I neglect OI dash F from OA, to find the shift, we neglect OA minus, okay, OA minus IF, sorry, IFA, final image A. Then we will get the distance of OIF, correct? We will get the distance of S, shift. So OA minus IFA, then we will get OIF. OIF is nothing but shift. Okay, so what is OA here? So O to A, O to A is x plus t. So OA is x plus t. I can write it here. S equal to OA is x plus t minus IFA. What is IFA? We found just now. IFA distance is t plus mu x divided by mu. Okay, so do the cross multiplication. We have mu x plus mu t. Then do the multiplication of negative symbol inside. We have minus t minus mu x whole divided by mu. Okay, then plus mu x minus mu x get cancelled. We have s equal to, I write it here, we have s equal to mu t minus t divided by mu. Take t value outside, s equal to t mu minus 1 divided by mu. Do the divide here, s equal to t, mu by mu is 1 minus 1 by mu is 1 by mu. Okay, so this is our final answer. Clear? We have to note down some important points before going to solve the problem. The first point, okay, note down. Rays are paraxial. Paraxial means the angle is very much low. Okay, angle between two rays. So we take sin theta equal to tan theta, which is equal to theta. So rays are paraxial. Then medium of both sides of slab should be same. It need not to be air always. It may be water or it may be oil, but it should have same medium. It should have same refractive index. Okay. Then third point, medium is not air, then we use this formula, S equal to T of 1 minus refractive index of surrounding divided by refractive index of glass slab. Okay, then fourth point, distance of object from slab. Distance of object from slab doesn't matter. Why? Because you see this formula, there is no symbol of x. Okay, so distance of object from slab doesn't matter. Wherever it is placed, no problem, we will get the same result. Okay, then fifth point, if shift value is positive, then shift is in the direction of incident ray shift in the direction if S value is negative, then shift in the opposite direction of incident ray. We solve the first problem. Find shift. We have a glass slab of thickness 15 centimeter. Object is placed somewhere here, and the distance of object to the interface given as 10 centimeter, and the refractive index of glass is given 1.5. So we have to find lateral shift. Okay, and this value also given 1, which means the surrounding medium is air. If surrounding medium is air, then what is the formula? S equal to T of 1 minus 1 by mu. What is T? Thickness given 15 centimeter. 1 minus 1 by mu. What is mu? Refractive index of glass, which is given 1.5. If you solve it, you will get the answer. Okay, move to the next problem. So find shift for this case. Here, what is the formula? You see, this is our glass slab which has refractive index of 1.5, but our surrounding medium have refractive index of 2, which means surrounding medium is not air. So if surrounding medium is not air, then we use this formula is equal to T of 1 minus mu surrounding divided by mu slab. Thickness given 15 centimeter, then 1 minus mu surrounding is 2 divided by mu slab is 1.5. Okay, so if you solve it, 1.5 minus 2 divided by 1.5, you will get the answer. Okay, which is in negative answer, which means the lateral shift. So images, this is our object, incident ray coming out from the object in this direction. If the value is positive, then our shift will be here, correct? But if the value is negative here, then our shift will be in opposite direction. So this is same direction of incident ray, right side. Opposite direction of incident ray means left side. So our shift will be here, correct? So you find the value of shift and post in group. In this problem, we have 3 slabs, composite slabs. Okay, so we have first interface between air and glass, second interface, third interface, fourth interface, fifth interface, and sixth interface. But we will solve it in very simple method. And thickness of first slab is 30 centimeter, second slab 20 centimeter, third slab 15 centimeter. Distance between each slab is 10 centimeter. Okay, slab is surrounded by air. Okay, and the refractive index of all the slab taken as 1.5 for all. As we have 3 slabs here, totally we have 3 shift. If we have 1 glass, then we have 1 shift, 2 shift, 3 shift. So our net shift will be, our answer will be S1 plus S2 plus S3. Okay, because we have 3 shift. So how to find S1? Simply use this formula, S equal to T of 1 minus 1 by mu, because it is surrounded by air. Then for S1, T of 1 minus 1 by u. So thickness of first slab 30 centimeter, 1 minus 1 by mu is 1.5, so 1 by 1.5. This is our S1. Then S2, for second slab thickness is 20 centimeter, 1 minus 1 by 1.5. Then for S3, third slab thickness 15 centimeter, 1 minus 1 by 1.5. You will get the answer S1, S2, S3. Then if you add all the three answers, you will get the final lateral shift, net lateral shift. Okay. Next problem. So before going to start the next problem, let me recall about mirror which you studied in 10th CBSE. This mirror is known as concave mirror. Okay, in concave mirror, light is reflected only inside the mirror. This is outside the mirror. Light is won't reflect if light falls on this outside. If light falls on inside, then it will be reflected. Okay, we have different parts of mirror. First one is this part known as pole, midpoint of the mirror, and here we have F means focus point, distance between P and F known as focal length. Okay, then here we have center of curvature, distance between C and P known as radius of curvature. Okay, can you remember all this? Then here we place our object. For example, if we place our object here, okay, then what's the distance between object and point P, which is taken as U. So U means object distance. Correct? If image forms somewhere, for example, if image form here, for example, so this is object. If image form here, then this distance known as V. V means image distance. So light ray passing, okay, one is passing parallel, then another is passing like this, for example. I'm just saying it for example. Okay, another is passing like this. Okay, pass like this. Then it meet here where the image formed. Okay, so this is our incident ray. Clear? So this is the short description of mirror which you already studied in 10th standard. Then you studied about mirror formula. What is mirror formula? 1 by F equal to 1 by V plus 1 by U, or 1 by U plus 1 by V, where F is focal length, V image distance, U object distance. Okay, then sign convention. What's the sign convention here? Focal length situated left side of the mirror, so all the distance from left side taken as negative. So here focal length taken as minus F. Then object also placed left side of the mirror, so U also taken as minus U. Image also forms in left side of the mirror, so image distance also taken as minus V. So all the distance left side taken as negative, right side positive, upwards positive, downwards negative. Okay, so we'll move to the problem. So here we have one glass slab and one concave mirror. Object is placed here. Okay, so light is coming from the object and it falls on the mirror and falls on the glass slab. Then it gets refracted. When it is coming out, it gets refracted again and it falls on the mirror. Okay, so here the thickness given as 15 centimeter and the refractive index of glass given 1.5, and surrounding medium is air, of course. Refractive index is 1. Distance between object, this is irrelevant data, we need not to do this data, but still it is given 25 centimeter. So all we have to do to find the lateral shift. And another important data given, that is focal length of concave mirror given as 40 centimeter. Okay, so first we come to this interface, first interface. For first interface, surrounding medium is air, so write the formula, shift equal to T1 minus 1 by mu. What is T? Thickness 15 centimeter, 1 minus 1 by mu is 1.5. So 15 1.5 minus 1 divided by 1.5. Then we have 15 0.5 divided by 1.5. So if we take 5 by 15, 5 by 15 will be 1 by 3. 1 by 3 is 0.333. So somewhat like that. 0.33 into 15. Okay, we will take 0.3. Here we have 5 centimeter. Correct? Not exactly 5, but we have nearly 4.999 something. So we will round off it 5 centimeter. This 5 centimeter is lateral shift in which direction? We have positive value, so in this direction. Okay, this is our lateral shift for first interface. Okay, so probably it will meet here, and this is our image. This distance taken as 5 centimeter. Then move to the next case. In this problem, this distance also given. Okay, this is also given 25 centimeter. Distance between glass slab and the concave mirror is given as 25 centimeter. So we solve it for concave mirror. Focal length is given 40 centimeter. So focal length always comes left side. Okay, left side of the mirror. So minus 40 centimeter by applying sign conventions. Then what is object distance? So image of first interface will behave as object of second interface. Now this is our object of this mirror. Okay, object of this mirror. So we have to find the object distance. The total distance 25 centimeter. Okay, this total distance 25 centimeter. Then if we neglect 5 centimeter, then this distance, okay, distance between I and interface, first interface will be 20 centimeter. Okay, 25 minus 5 will be 20. Then 20, again here we have 15, 20 plus 15, 35. Again here we have 25. So 35 plus 25 will be 60 centimeter minus 60 centimeter. Okay, now apply mirror formula. 1 by f equal to 1 by u plus 1 by v. So 1 by minus 40 equal to 1 by minus 60 plus 1 by v, that we have to find. So 1 by v equal to 1 by minus 40 minus 1 by minus 60. Correct? So minus into minus will become plus here. 1 by minus 40 plus 1 by 60. If we solve it, we have here we have 6 into 4, 24, 2400. Then 60 minus 40. Correct? We have minus 2400 because here we have minus 40. So 60 minus 40 will be 20 divided by minus 2400. 0 get cancelled. 240 will be minus 120. So 1 by v is 1 by minus 120. Then v will be minus 120 centimeter. So what is this v? This 120 is not our answer, but 120 is image distance. So we have to add lateral shift with it. For shift formula, right here s equal to t of 1 minus 1 by mu. Okay, so 15, which I already found, I think 1 minus 1 by 1.5, which comes out to be 5 centimeter. Okay, so our image will be somewhat here 120 centimeter. Then again our lateral shift will be 5 centimeter. So the total shift will be 120 plus 5, which is equal to 125 centimeter. That is our answer. Okay, thank you.